Okay, in this video, we're going to look at probability and actually setting up probability. We've talked a lot about counting principles, but single numbers. Again, now we're going to move into introduction of probability, a counted number divided by a counted number. So we're going to entitle this lesson, I think 10D we're at right now. Okay, and here's the basic, what you have to know. Here's the main objective, understanding the setup probability. A counted number divided by a counted number. So it has a couple of different terms here. Probability is the number of successful outcomes divided by all possible outcomes. Okay. So an event is a situation that you are trying to take the probability of. So outcomes in an event that you want to be successful. Okay. And that's the key word that we're going to use there. Successful outcomes, successful events here. Sample space is the total number of possibilities that are possible. So if I'm talking about what's the probability of winning a lottery, well, obviously there's only one successful winning ticket, one combination of numbers that win. But obviously there's millions of possible number combinations you could pick. So all the different possibilities of lottery tickets is your sample space. The successful outcome, the event, is the one that you want. So that's success over total sample space. So those are two kind of new words for us there, sample space and event. And we'll talk about an event because we may have several different events later on where you have to work a probability for different events. All these situations are for a single action happening at one time. So you're picking not one item, but you're picking a single group or an item at a time, okay, not multiple things at different times. So we'll talk about that a little bit later. Now, another thing is probability can be written as a fraction, ratio, or percentage. A lot of times we set it up as a fraction, which obviously is a ratio, and then obviously percentage is just a decimal way or a different form of showing a fraction. But a lot of times we're going to deal with everything in fractions. A lot of times we don't deal with percentages when we're talking about what probability. We'll talk about percent of likelihood, but all of our answers in this class will be written as a fraction or ratio. Now, let's talk about perfect probability and incomplete probability. Probability goes from 0 to 1 because the total amount of outcomes, your sample space, is always your largest number. So your largest number always goes in the bottom. Well, probability means that there are no success out of all possible attempts. So you have the big number on the bottom, but 0 on top. The perfect probability of 1 means that you have the same number of successes as you do possibilities. Okay, and again, there are very few things that have perfect probability, and you may have numbers that are close to perfect probability. So there's always the statement, you don't have to do anything except for die and pay taxes. And die and pay taxes, the argument of that statement is that's the only two things in life that has perfect probability. Everything else, could happen, could not happen, and then there's some different degrees of success. For perfect probability to happen, it means every single attempt. So if you have 10 red shirts in a drawer and I pick a single shirt at random, what's the probability it's going to be red? Well, every single shirt's red, so the probability is 1, perfect probability. What's the probability I'm going to pick a blue shirt? Well, since there's no blue shirts in the drawer at all, it's impossible for me to pick a blue shirt from a pile of red shirts, so that would be 0 probability. So that's just a little bit talking about that. Now, let's talk about notation. Probability is notated as P and then in parentheses event. So if I'm talking about the last scenario of picking a red shirt, I would say what's the probability of picking a red shirt from a drawer of red shirts? That'd be 1. What's the probability of picking a blue shirt from a pile of red shirts? And that would be 0. So that is how you would write the examples or properly know how to do this. Notice another example here, tossing a coin. What's the probability in heads? Well, there's one successful side that is a head, and there's 2 sides in a coin, so the probability 1/2. Okay. Now again, for this first video here on 10D, all these will be pretty straightforward numbers. So we're just getting used to probability setup. And as we advance, obviously we're going to apply more of the counting principles we've learned thus far. So I'm going to go through these first 5 examples and just as see where we're at. Okay, so Miss McGinnis says 12 pencils to desk, 4 are sharpened and 8 are not sharpened. If Joe reaches in to grab one pencil without looking, what is the probability that it's sharpened? So a lot of us would say, um, how many successful pencils are there? Okay, and what's probably to be sharpened? So sharpened is success. There are 4 that are sharpened, so there are 4 possible successes. What's the sample space? 12. So the event itself is picking the pencil. Okay, so that's the event. The sample space is 12. The probability is 4 or 12. Obviously, we always want to choose 3. Um, just do 1 over 3. Okay, take a 4 out both the top and bottom. So probability of picking a pencil that is sharp. So that's how I would write that. Okay. Now, a lot of us saying, can we use combination permutation? Sure. Since you're picking, the order doesn't matter, and we're really just picking one thing. So how many ways that you have 12, choose one. There's 12 is what this is. It's 12 items. You're choosing one at a time. Now think about this, and this goes back to that 0 principle we talked about before. If there are 4 pencils that are sharpened, so this is the sharpened side, and you want to choose one of them, and there are 8 pencils that you want to choose none of them. So you really have the exact same setup here. So this is the 4 divided by 12, and notice 8 choose 0 is equal to 1. So you'll see me in a lot of my examples doing setups like this. And I think this is important because as we get more complex problems, I think it's important to account for everything in the sample space. Okay. Let's look at number 2 here. In the sample space 1 through 25, what are the probability of picking a prime integer, and a multiple 3? So these are really 3 separate events. Okay, so the first one is picking a even number. Okay, well, let's talk about it. We have 2 through 24, so that's going to be a total of 12 even numbers. Okay, so 12 divided by 25. Okay. So that's a probability because there's 12 even numbers, 2 through 24 and opposite evens. So what's the probability of picking a integer? Okay. Well, notice all of them are integers, so there's 25 of them divided by 25, so that equals to 1. So that's the perfect probability we talked about before. Okay. Oh, I'm sorry, I read it wrong. As a prime integer. Okay, so that would just be plain integer. Let's talk about a prime integer. Okay, so something that's prime. Well, let's go ahead and list the prime ones. We have 1, 3, 5, or actually 1 is not prime because it's the same number. So we're talking about 2, 3, 5, 7, 11, 13, 17, 19, and 23. So I got, I think 9, I counted out there. 9 prime numbers divided by 25. Okay. And then we have the probability of a multiple of 3. Okay, so multiple of 3. And I guess I'm just abbreviating there, but I do this so we can kind of organize our notation. And so multiples of 3 are 3, 6, 9, 12, 15, 18, 21, and 24. So that's a total of 8. Okay. And hopefully I counted right on all those. But that's the principle we're shooting for. Okay. And now anywhere where you can reduce, you want to, as we did here. And that's the point there. If you're dealt 3 cards, what's the probability that all 3 are spades? So again, I'm going to use the choose function here. So you were dealt 3 cards. So I'm going to do 52, choose 3, because the order doesn't matter how they're dealt to you as long as you got 3 in your hand when you're done. And I'm talking about spades versus non-spades. So the spade number is going to be first. So I'm going to put that over here. And how many are spades? Well, there's 13 that are spades. And I want all 3 of them to be chosen. Now that leaves there's 39 cards left in the deck, and of those 39, I want none of them. So I have spades and then non-spades. And then that's our setup there. Okay. And again, I'm not going to plug these into the calculator right now. I'm more concerned about the setup. You can go ahead and do that on your own. Okay. Let's put out, so you'd want to get a number there, reduce it on your calculator, get a simplified fraction. If you're dealt 3 cards, what's the probability all 3 are kings? So it's the exact same idea, but we only have 4 kings. You want to choose 3 of them. And there are 48 cards that are not kings. You want to choose none of them. Okay. And again, we have 52, choose 3. Now again, notice on both these problems here, the front numbers add up to the front number and the back numbers add up to the back number. So that accounts for all possibilities in the sample space, and then 3 accounts for all successful possibilities. Same thing down here. 4 and 48 make 52. 3 and 0 make 3. So I have accounted for everything. All right, let's go ahead and take a look at number 5. Mr. McGinnis has 12 pencils in his desk. 4 are sharpened, 8 are not sharpened, very similar to the first one. If Joe reaches it and grabs 3 pencils without looking, what's the probability that all are not sharpened? So I'm going to set up just like the card problem. So we're talking about 12, choose 3. So I'm picking 3 as a group. And I have sharpen versus non-sharpen. So again, multiplying these. So how many are sharpened? Well, there's 4 of them to sharpen. 3 pencils without, what's probably they are not sharpened. So of the sharpened ones, I want none of them. And of the non-sharpened ones, 8 of them, I want all 3 to come from that category. So right there is my setup. Okay, and again, we reduce as a fraction. Okay, so this is a little introduction to counting. For probability based on what we learned on counting. So notice, very quickly we can understand the principles of it, but, notice 3, 4, and 5, we kind of incorporate a little bit of the counting principles. So we're going to work on this. The other videos will focus on special cases of probability, talking about what happens when you have different events and how those related. So this video is focused on just a single fraction, a single event, sample space, and accounting for everything in that sample space.